Assalamu alaikum students. Today we are going for a new paper and this is a mechanics paper. Same year, October, November 2019, paper 4.1 is there. So let's start with its very first question. And it says that a crane is lifting a load of 1250 kg vertically at a constant speed V. Given that the power of the crane is 20 kilowatt, find the value of V. Now if you see here, that it is lifting a load. Let's say this is the load and this is 1250 kg and its weight is obviously W equals to mg, so 12,500 Newton. Now since it is lifted upward, so the force will be upward, and here the speed is constant. Since the speed is constant, so upward force and downward force must be equal. So we have a formula for the power. Power is equals to force times by speed. So speed is equals to power over force. And the power is 20,000 watts and force is 12,500. And if you use the calculator and simplify it, this becomes 1.6 meter per second. Now let's go for the second one. Okay, here it is. It says a cyclist of mass 75 kg. The cyclist sends a straight hill 0.7 kilometers inclined at an angle of 1.5. Her speed at the bottom is 10 meter, at the top is 5 meter per second. There is a constant resistance to the motion which provides the work done against the resistance is 2000 joules. The cyclist has a constant force of magnitude F Newton. Find that the value of F. So let's draw this diagram first so that we will be easier to calculate its value. The angle which the hill is making is 1.5 degree. And the total distance of the hill from the bottom to the top is 0.7 kilometers. That actually means the distance is 700 meters. Now, if we assume that there is the cyclist, and since her mass with the cycle is 75 kg, so it's going to be 750 Newton its weight. If we resolve it into horizontal and vertical components, this angle is going to be 1.5 again. So this value is 750 sine 1.5. This value is 750 cos 1.5. There is a constant force F applied to this direction. This is F. And this 750 sine 1.5 will be going downward here, this one. And along with it, there is another force which will be provided by, there is another resistance force which gives a 2000 joules work here. So let's see it now. That first of all, let's go for the acceleration. 2as is equals to v square minus u square. So acceleration is equals to v square, and it's given that at the top the speed is 5 and at the bottom the speed is 10. So 5 square minus 10 square divided by 2 times 700, and this gives us minus 3 over 56 meters per second square. Now, it says there is a work done against the resistance that is 2000 joules. So work is equals to force times by distance. So force, which is the resistive force, is work over distance. Work is 2000 and the distance travel is 700. So this gives us 2.86 newtons if you use the calculator. Now this is 2.86. This is the force which is resisting, and this is only the force which is dragging the cyclist up there. So F minus R is equals to MA. We don't know how much is F, but there are two resistive forces. One is 2.86. One is 750 sine 1.5 equals to MA, which is 75, and acceleration is minus 3 over 56. Now the rest is the simplification, that if we shift all of them to the other side, we are able to get it 18.47 Newton, which is nearly equals to 18.5 Newton. I hope this is clear to you. Let's go for the third question now. And the third question says, okay, the third question says, a block of mass 3 kg at rest on a rough inclined plane, 60° to the horizontal, a force of magnitude 15 Newton acting up the line of greatest slope of the plane, and is just sufficient enough to prevent the block from sliding down. And so it means it is sliding down. So let's draw the diagram first. This is the situation here. This is 60°. Here is the box, which is 3 kg. So the weight acting vertically downward is 30 Newton. And if you resolve it into horizontal and vertical components, this is going to be 30 sine 60, because this value is going to be 60° as well. And here it is 30 cos 60°. There is a force of 15 Newton acting up the line of greatest slope. Now find the coefficient of friction between the block and plane. So let us find how much is the difference of these two first. This is 30 sine 60. Since it is still sliding down, so there is a force of resistance which will be acting upward. So according to the law, 15 plus R, since it is in equilibrium, equals to 30 sine 60. And if you simplify this, this gives you R is equals to 11 Newton. Now, this R is the frictional force, and for finding the coefficient of friction, we have F equals to mu R. F is 11 Newton, which is the frictional force, mu, and the normal component is this only, 30 cos 60. R is the normal component, and this 30 cos 60. So mu is equals to 11 over 30 cos 60, and which gives us mu is equals to 0.73, a constant quantity. Now let's go for the next. What does it say? Okay. The force of magnitude 15 will be replaced by a force of x Newton acting up the line of greatest slope. So it's pulling the value up. So the friction and 30 sine 60 both are going down. So what will be the value of, but it is not be able to move. Find the greatest value for which the block does not move. So x is going to be 50. Fx is going to be, we have 30 sine 60 plus the frictional component that was 11. Frictional value was 11. So if you add both of them, you get it at equals to 37. So this is all about the first three questions. And in the next tutorial, we are going to go for the next questions, remaining questions of this paper. I hope this small explanation will be helpful for you to solve this paper. Thank you so much. Good luck, and don't forget to subscribe to the channel and view it whenever it's needed to you. Thank you. Stay blessed.